Welcome back. In this section, 10.7b, we're going to look at quadratic equations and try to determine what is the best method to solve them of the four methods we've been given so far. These four methods we've used in this chapter are square roots of both sides, factoring, completing the square, or the quadratic formula. Now, these are probably in order from easiest to hardest. The quadratic formula works for every single problem, but it's the longest, and taking the square root of both sides is the quickest and shortest method. As we look at our problems, we want to identify which one has the best methods for each example. If you want to take the square root of both sides, look for an equation that has no x term. When I say that, I want to think and take you back to our standard form of ax squared plus bx plus c equals 0. When I say no x term, I mean there's no b or x in the problem. So as we look at our 5 examples below, we try to determine which one of these 5 doesn't have an x term. Well, very obviously, that is the first example. And so we're going to solve this first example by taking the square root of both sides. Let's analyze then and continue. Our next easiest problems to identify where it is to work has to do with factoring. Factoring is generally easiest if you just have an x squared in the front end. So, each of these are already equal to 0 on 3, 4, and 5. But as we look at them, I can't think of anything that multiplies to 10 that adds to 6, because 1 and 10 don't, and 2 and 5 don't. Down here at the bottom, however, I can think of something that multiplies to negative 6 that adds to negative 1. So I'm going to solve this second one by factoring. This third one, can you think of something that multiplies to negative 1 that adds to 3? I can't either. So it looks like this fourth one is the only one that really works with for factoring. Now we look at for completing the square. Completing the square is best accomplished if the first term is a 1x squared and the middle term is even. Of our remaining 3 problems, the only one that qualifies for this is our third one, a 1x squared and an even middle term. And so we're going to do this third one with completing the square. That means our last 2 problems are going to have to be done with the quadratic formula. Remembering the quadratic formula is the easiest to do, but it is long. Easiest because it always works. So, let's take a look and practice some of these problems together. The first one we're going to practice is a problem solved by using square roots. So let's look at our first example of 4x squared minus 36 equals 0. Well, very simply, we isolate the 4x squared by adding 36 to both sides. Then, we're going to have 4x squared equals 36. We now divide both sides by 4, giving us x squared equals 9. When we have the x squared isolated by itself, we're allowed to solve it by taking the square root of both sides, remembering to put the plus or minus in front of the square root. That gives us our answers of x equals either plus or minus 3, and written as a solution set, obviously, it's going to be negative 3 and positive 3. Now let's look at our next example. Let's use factoring to solve a problem. The problem that we're going to do for factoring, we can work in example 2 on page 2. And so that's the problem, x squared minus x minus 6 equals 0. Remember, when we're doing factoring, we're going to use the method called the MAC method. What multiplies to the first term adds to the middle, and we'll choose our answer. So it multiplies to negative 6, and then we have to remember there's really a 1 in front of the minus 1x. So 1 times negative 6 is negative 5. 2 times negative 3 is negative 1. That's our answer. So those will lead us to our factors. Our 2 factors are found. We have an x and an x, and then we can use the plus 2 and the minus 3 from our factor tree over on the right to fill in our factors. We set each factor equal to 0, and then we're going to solve each factor. We subtract 2 from both, add 3 to the other, and get our answers of x equals -2 and x equals +3. Hopefully you realize that this is a very simple method to use, but it only is going to work in some cases. Let's review now our quadratic formula problem. Let's do number 2 for the quadratic formula. That's 3x squared plus 2x minus 17 equals 0. And as we look to work this problem through, we're going to have to remember to identify the values of a, b, and c. Our values of a, b, and c in our problem are 3, 2, and -17. I'm going to split my paper into half, and I'm going to have to write kind of small to fit this all in. Let's write our quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In our first step, we're going to input our numbers. The opposite of 2 plus or minus 2 squared minus 4 times 3 times -17 all over 2 times 3. Help me with this one. X equals the opposite of 2 plus or minus the square root of 4. Now we have a minus and a minus. That's going to be a plus. And then we're going to have 4 times 3 times 17. Well, that's 204. All over 6. That gives us -2 plus or minus the square root of 208 divided by 6. I take the square root of 208 and I get 14.42. So I have -2 plus 14.42 over 6, or -2 minus 14.42 over 6. We simplify each one. -2 plus 14.42 divided by 6, and that's 2.07. On our other side, we have -2 minus 14.42 divided by 6. Seems I'm having some problems on my calculator here. -2 minus 14.42 divided by 6. Our other side, we have -2.74. So written as a solution set, that's -2.74, comma, 2.07. Our last one that we're going to do as an example is completing the square from the first page. So that's x squared minus 6x plus 10 equals 0. X squared plus minus 6x plus 10 equals 0. Our first step on our completing the square problems, if you remember, is to move the 10 to the other side as we work our problems through. We're then going to put plus blank and plus blank on both problems. We then take half of 6, square it, and add it to both sides, and that's a 9. Rewrite it as a binomial squared, x minus 3 equals a -1. We now take the square root of both sides, and we take the square root of x minus 3 squared and the square root of -1 squared, remembering the plus or minus. It seems on this problem we're not going to have to go any further because the square root of -1 doesn't exist, and so our answer is no real solution. Had the problem been possible, we would have continued and probably gotten a decimal answer of one way or another. Hopefully this is a good review of how to solve our problems using our 4 different methods of a quadratic formula. Those are using square roots, completing the square, factoring, or the quadratic formula.